Welcome back, everybody. We are going to be solving exponential and logarithmic equations. And so our base exponent property means that for any a that's greater than 0, again, a is our base, and so we want it to be positive and not equal to 1. Then we have this property where we want the base to an exponent equals the base to another exponent, and then we can drop the bases and then get the exponent. So the thing that we want to look for is how do we get our expressions to be the same base, so that way we can drop the base. Okay, so if we look at example 1, we have 2 to the 3x minus 7, so we want to try to get 32 to be the base of 2. And we know that 2 to the 5th power is 32, so we can write this as 2, 3x minus 7 equals 2 to the 5th power. And so since our bases are the same, we can drop the base, and we have 3x minus 7 equals 5. And so now we can just finish solving this equation like a regular linear equation. So we add 7 to both sides. So we have 3x equals 12. Divide by 3. So we get that x equals 4. Now, if we do not have a way to get the same base, so in example 2 we have 3 to the x and 20. 20 is not, we cannot write it to be 3 to any sort of power. And so if we do not have the same, if we can't put them in the same base, then we have to use logarithms to solve. And so you can either use the standard log or ln. I personally prefer to use ln because it's less to write. So this would be ln of 3x equals ln of 20. And then we use our exponent rule, so we can bring x down in front. Ln of 3 equals ln of 20. Then divide by ln of 3. So we get that x equals ln of 20 over ln of 3. We can type this into our calculator to get an approximate. Regardless of if you use ln or log, you should get the same answer. But I want to make a note of how to enter this into our calculators. So we either want to use this alpha y equals function, or if you do not have that ability, you have to be sure to put parentheses around it, and then it was ln of 20. And so in this case we need 2 parentheses divided by ln of 3. And so we would get that this is approximately 2.7268, so I'm going to round that to 2.73. So this is approximately 2.73. And then for example 3, before we can either drop the base or take the log of both sides, we need to get our exponent by itself. So in this case, we would want to divide by 100. So we get e to the 0.08t equals 25. And so in this case, we actually want to do ln of both sides. So this would be ln of e to the 0.08t equals ln of 25. And if you remember, ln and e are inverses of each other, so these will cancel each other out. So where we have 0.08t equals ln of 25. So then we would divide by 0.83 to get that t is equal to ln of 25 over 0.08. And so this would be approximately 40.2. And so we will save examples 3 and 4 for class, 4 and 5 for class. And so when solving logarithmic equations, what we want to do is get a single log on one side, then switch forms. So what I mean by that, in example 1, we have log base 3 of x equals -2. And so we want to switch this. So that way it is 3 to the -2 equals x. And then remember that 3 to the -2 is 1 over 3 squared. So this will be 1 over 9 equals x. And so again, this step right here is just switching from logarithmic to exponential form. And so before we can make that switch, we have to get a single log. And so in this case, we want to combine these two logs. So we're adding, which means that we want to multiply inside the log. So this will be log of x times x plus 3 equals 1. And remember that if no base is written, it is understood that the base is 10. So this means that we would have 10 to the first power equals x times x plus 3. So we would distribute, so we have 10 equals x squared plus 3x. And now we have a basic quadratics, which means that we want to bring the 10 to the other side. So we have 0 equals x squared plus 3x minus 10. And so we can either factor, use the quadratic formula, etc. to solve this. So I'm going to factor, because this is x plus 5 times x minus 2, which gives us that x is equal to 5, or x is equal to -2. Now, one thing that we have to be careful with logarithms, because with exponents, our domain is -infinity to infinity. So whatever our x value that we solve for will be okay for us to use. But with logarithms, we cannot take the log of a negative number. And so because we have log of x right here, we cannot have x equaling -2. If it were just the log of x plus 3, then that would be log of -2 plus 3, which would be log of 1, which is possible with 0, but we cannot have log of -2. And so because of that, we have to exclude x equals -2 from our solution, and x equals 5 is our only solution. So we will talk about examples 8 and 9 in class. So have a good day.